So today we're doing systems of equations, the second set of notes, and we're going to talk about two different strategies other than graphing today. So the first method we're going to talk about is elimination. You can either choose to eliminate your x's or your y's, so I would always look to see which one requires the least amount of work. So when I look at this problem, notice that my x's line up. I have one that is a positive 4x and I have one that is a negative 4x. So that's always a good sign because that means if I put these two equations together, my x's are going to cancel out without me having to do anything. So we're going to turn this into one big plus sign. Okay, so we're going to add these two equations together. When I do that, my x's are going to cancel and I'm going to be left with 5y. And I add the 9 and the 16, and we get 25. Now I can divide both sides by 5 because I'm left with one variable instead of two, and we're going to get that y equals 5. But you know from yesterday that solving a system of equation means you are supposed to get an x and a y value. So I know y is 5, so we need to find the matching x value. You can choose to use either equation. I'm going to use the top equation, but you can gladly use the bottom. And everywhere I see y, I'm now going to replace y with what it's equal to. So in this instance, it's 5. And now I just solve for x. So I have 4x plus 10 equals 9. I will subtract 10 from both sides. And I get 4x equals negative 1. And then we divide both sides by 4, and I get that x equals negative 1/4. If I wanted to kind of tie this into yesterday with graphing, if I wrote it as a coordinate pair, it would be negative 1/4, comma 5. So the reason graphing isn't always the best method is here, notice that the intersection would be happening at a decimal, and that is not ideal for graphing. So instead of doing the example letter B, I would like to do a more challenging problem. So I would like you to go to the practice section, and we're going to do letter B of the practice section as your example. So you still have 4 other remaining problems to do on the page for practice. So for this one, notice none of my variables match up or cancel out. So we're going to have to force it to happen. Typically, students prefer to cancel x's over the y's. It really doesn't matter. So you always will look at the two equations and determine what your GCF is. So let's go with the x's. I have a 6 and a 5. So my GCF between those two would be 30. So I have to multiply both of these equations by a value to make those x's become 30. So the top one I'm going to multiply by 5. And the bottom one I'm going to multiply by 6. But the problem is right now, if I multiply those both out, I would get a positive 30. So both of these would be giving me positive 30. And I need one of them to be negative in order for it to cancel. So I'm just going to make my top one be negative. Again, you could make the bottom, the 6, be negative. It doesn't matter. So now I'm going to get negative 30x. And we're going to distribute this to all 3 terms. Minus 35y equals negative 45. Okay, so definitely don't neglect those 2 numbers over there. Then going through my bottom equation, now I'm multiplying everything by 6. So I get 30x plus 12y equals negative 24. And now we're going to turn this into one large addition problem. My x's are going to cancel. I'm left with negative 23y equals negative 69. Don't know what happened there. And then my last step would be to divide by negative 23. And I'm going to get that y equals 3. But again, as you know, you are not done. You found y. Now I need to find x. So now I need to go back through and I have to plug that back in. So I'm going to use the bottom one this time. So I have 5x plus 2 times 3 equals negative 4. And I get 5x plus 6 equals negative 4. I'm going to subtract the 6 over from both sides. We get 5x equals negative 10. Divide by 5, divide by 5. And I'm just going to come up here because I ran out of room. And x equals negative 2. So at this point, you have 4 problems remaining on the page. So you are going to try those, and we'll discuss your answers tomorrow, or however I have you submitting those answers. Moving on to the next page of substitution. So now we're going to discuss how to do the substitution method. So the substitution method sounds exactly as it is. I'm substituting something in. So here they're saying that y equals x plus 4. So I'm going to come down to that second equation, and I'm going to replace y with what it's equal to. So I'm going to have 3x, and then instead of y, I'm going to replace it with x plus 4. It's always a good idea to substitute it in with parentheses, just in case there's a numerical value in front. So there is nothing there, so I can drop the parentheses, and I can combine like terms, and I'll get 4x plus 4 equals 12. I'm going to subtract 4 from both sides. Come up here because I'm running out of room. 4x equals 8. Divide by 4, and we get that x equals 2. So completely different approach, still works, but again, I need to now find what y equals. Definitely use that top equation because that top equation says y equals la 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 la. So now I'm going to take that equation and I'm going to plug my x value in, and we get that y equals 6. So the solution would be 2, 6. So for letter B, again, you know that y equals x minus 3. So I'm going to come down here and I'm going to replace y with x minus 3. So I have 2x plus 2 times my y value equals 10. So I'll just use a different color here so you can get a good visual that I'm putting the x minus 3. So that y value up there is going into the equation. But this time I have to distribute the 2. So I will get 2x minus 6 equals 10. I add these two together and I get 4x minus 6 equals 10. I'm going to add that 6 over. So now I'm at 4x equals 16. Divide both sides by 4, and we get x equals 4. Again, at this point, you've done all the hard work. The easy part is the last step of just substituting it back in. So I have y equals 4 minus 3, so y equals 1. And if I wanted to write it as a coordinate pair, I could say 4, 1. So one more example for substitution. Letter C says x equals y plus 2. So now they're giving you the x, and they're saying that it's equal to y plus 2. So I'm going to come down here to that x and replace it. So I'm just going to get myself set up. Okay, so now I'm going to leave the opening in the x spot, and I'm going to substitute that x value in, which is y plus 2. We're going to distribute that 2 in, so I'll get 2y plus 4 minus 4y equals 2. We're going to combine like terms, so that will give me negative 2y plus 4 equals 2. And we're going to subtract 4 from both sides. So now I'm at negative 2y equals negative 2. Divide both sides by negative 2, and y equals 1. Now I come back up to that top equation, and it'll say x equals y, which is 1, plus 2. So x equals 3. So the key to using substitution is, if you notice all through those problems that we did, you had one variable that was isolated by itself. When you have that, substitution is definitely the more direct and easier method. If you don't have one variable that's by itself already, then you would want to go the elimination route. So the next 5 problems of practice, the directions say use elimination or substitution. So whichever method you think would be the easiest or appropriate is the method you use.